Tower, all other things. Nowadays, you have a building, apartment, or some building. You'll be having canopy here. So you stand here and throw a ball. You go like this. Very simple, no? So maybe some few 100 years back, okay, it was something tower. Nowadays we have high-rise buildings. From there you throw a ball. The ball will go and will strike the ground. We are discussing motion of such ball here, nothing big. High-rise building. Oh, just building, you write it. Yes. From here you throw a ball. The ball, what is the path of the ball? The ball will go, will ascend, then will descend, will come and finally strike the ground. With what speed it will strike? At t equals 0, I threw the ball. Then after certain time t, it will come and strike the ground. We have to calculate this time of flight. What is the maximum height ascended? All the quantities. Now, what is the path of the ball? The ball is going to ascend, then it will descend, and finally it will strike the ground. With a speed v. I'll make this tower little bit. I think, okay, no, it looks very neat. So when it is projected at t equal to 0. Let me the point of projection, let me take one, highest point 2. Again, it will be at same level. Then let this be 4. Finally, it will be at 4. So then it will ascend at some height h from the tower. It will come to instantaneous rest here. Say just take some ball, go outside. Just go outside and project it. Nothing to you. Just go outside. Stand on certain high rise like a canopy or say some cliff or something like a hill, something. From there you throw a ball. So the ball will rise up, then it will fall down. This motion is what we are discussing here, nothing big here. No. So at 2, what is the state of ball? Ball will be instantaneous rest. It will be at rest for a while. Then it will fall back. Okay, first, like what is the time of ascent, time taken to move from 1 to 2? What is that h? We'll find out all these things because we know like a first thing, 0 is equal to u minus, how is g? G will be acting vertically down. So how is g? Opposite initial velocity. So therefore it is plus minus g, time taken to move from 1 to 2. How much? T12 equal to u by g. What is T12? Time taken for the ball to ascend from the top of the tower to highest point of its trajectory. Okay, there's a one thing. Then what is this h? Again, 0 square minus u square equal to minus g plus h. Now these are very important, like plus h. Why this h positive? It is measuring the direction of initial velocity. G opposite initial velocity. So therefore, finally h equal to u square by 2g. Height ascended by the ball above the tower. Then time t3. I think we already know time of ascent should be equal to time of descent. This already previous class we had this one. Now I'm interested how much of time it will take to come and strike the ground. What time it take to come and strike the ground? Okay, let's write the equation. This is the initial point. I don't have space to scribble. Okay, this is the initial point. This is the final, no? Look at the displacement. How is the displacement? The displacement is equal to h minus h. So therefore the convention, then u t plus minus g t square. So when you're using equations of motion, so you have to substitute the quantities like a velocity, displacement, acceleration with the sign. So what is the sign convention here? Look at first the displacement. It is opposite to initial velocity. Initial velocity is u upward. And how it is opposite to initial velocity? So therefore minus h. Then what about gravity? It is measured opposite to initial velocity. Therefore it's negative sign. Not based on the motion. So it's not like so it is moving here. Now it is moving opposite to g. Afterwards it moves in the direction of g. Why don't you write plus or minus? No, not like that. The sign there, when in the equations of motion, the sign for velocity, acceleration, displacement is based on the initial velocity. If they're directed opposite to initial velocity, negative. If they're directed in the direction of initial velocity, they should be positive. Okay, there's a quadratic equation, gt square minus ut minus h equal to 0. So then t is equal to u plus or minus u square minus 4g minus h by 2g. Okay, this will be the time of flight. So what we should call time of flight or time taken by ball to move from top of tower and reach the ground. Yes, it will come and strike the ground after a certain time. This is called like a time of flight. In short, we'll call time of flight. With what speed it will strike the ground? So that also will calculate minus v whole square minus u square 2 minus g minus. Very, very, very important. I'm really interested. The signs are something very, very important. Look at that. Minus v square minus u square. So why negative sign for v? It is directed opposite to initial velocity. Not visible. I'll make it other contrast colors. Okay, no. Look at this velocity, final velocity. It is directed opposite to initial velocity. So therefore, it will be negative sign. Why g negative? Directed opposite to initial velocity. So therefore, negative sign. Why h negative? The displacement is opposite to initial velocity. Solving this is what needed. V square equal to u square plus 2gh. So the ball will come and strike the ground with a speed v. These are some quantities which we'll be using. There's a time of flight, and this is the speed with which ball strike the ground. So what will write? Speed with which ball strike the ground. What about at 3? What is the state of the ball? It will be moving with the velocity. So what is that velocity is equal to? Here it will be moving with a velocity, say v3, which is equal to u only. Able to get this? So definitely between 3 and 4, can you apply S? You'll get the same answer. So motion of the ball, will see here or the state of it. It will have say some velocity VA and the retardation will be downward. What about here? Here it will be accelerating. So what type of motion the ball will be describing? First retarding motion, then freely falling. It will pass through that initial level and will come and strike the ground. I think the same thing, no? You stand at the canopy, balcony, what you can call, from there you throw a ball, the ball will ascend. Again, it will pass through, you know, then go and strike the ground. That particular motion of such a ball is what we are describing here. Okay, let's go for plotting of the graphs.